Hello, welcome to the SAP HANA Demo session. In this session, I'll be showing you the details of SAP HANA, why it's called an in-memory database, and how's the hybrid structure of SAP HANA, wherein I'll be showing you how come row store is different from column store. And later on, we'll be working on SAP HANA Live environment, that is in SAP HANA Studio, wherein I'll be showing you how to create the different objects and how come different perspectives are different from each other. So let's just start with SAP HANA. As you know that it's called an in-memory database. So why it's called an in-memory database? Because the whole database is now kept in the main memory. That's why it's called the in-memory database. Rather than keeping the whole database and performing all the read and write operations from the disk, now the database is kept in the main memory and all the read operations are performed from the main memory. That's why the real-time operations are possible. That's why we say that with SAP HANA, now the transactional data is accessible in real time because it's kept in the main memory, and now all the disk input output bottlenecks are not there, and it has the faster execution. So HANA also leverages the hardware innovations like multi-core CPUs and high capacity RAM. So that's why now it has all the fastest operations, all the read operations are fastest. But it also uses the disk storage for permanent persistency. See, it holds the entire database in the memory, but it uses the persistent storage as a backup in case of failure. So because main memory is volatile, so in case of power failure we have the backup storage on the disk, and so all the data and the logs are automatically saved to the disk at regular save points, and the log is also saved to the disk after each commit of the database transaction. So the disk write operations happen asynchronously. It's not like that after each transaction the disk write operation is performed. No, after some point at the save points or after committing only these disk write operations are performed. And it also SAP HANA provides us with parallel processing because of its multiple core CPUs. Now higher CPU execution speeds are achieved. And then we have the hybrid data store. By hybrid data store, it means that it supports both the column store as well as row store. What happens in column store? See, you can see over here the table. It has got 4 records. This is a traditional table in the form of rows and columns. In case of row storage, the data is stored as a sequence of records, each of which contains the fields of one row. Okay, so you can see over here it is a sequence of the rows which are stored in the linear memory. So first the whole record, first record is stored, then the second record is stored, then the third record. So it's the whole record which is stored in the continuous memory, in the contiguous memory locations. But in case of column store, you can see over here that first the entire column is stored in the contiguous memory locations, then the next column, and after that the next column. You can see over here first US, JP, UK. That's the first column for all the records. So it's stored like that. For all the records, the first column will be stored. Then for all the records, the second column will be stored. Then for all the records, the third column is stored. So this is how the column store works. See, use of column store will help to prevent the table scan of unnecessary columns while performing searching and aggregation operations on single column values stored in the contiguous memory locations. Suppose you have some query which works upon only the country column. So in that case, this column store is faster because you can see that all the column country names are stored over here in the contiguous memory locations, so it will work faster. Whereas in case of row store, if you have to work upon this country column, then first you'll have to find out this US. Then you can see over here you'll have to jump from here, and then for every column value you'll have to jump to different memory location. Whereas in this case these are in the contiguous memory locations, so it's faster. With row oriented storage, the same operation would be much slower because of the same column is distributed across memory, and the CPU is slowed down by the cache misses then. So, this combination of both classical and innovative technologies of data storage and access allows the developer to choose the best technology for their application, and where necessary we can use both of these in parallel as well. So, having both read optimized column store, because this column store is used for read operation, so it is read optimized, and this row store is used for write operation, so it is write optimized row store for OLTP. So both the stores are in the memory. Using the column stores in OLTP application requires a balanced approach. So we basically have the read optimized column store ideally suited for OLAP, and write optimized row store ideally suited for OLTP systems. So this is how we store the data in SAP HANA. Now I'll be showing you the SAP HANA Live Studio, HANA Studio, wherein I'll be showing you how do we create the different tables, how we have the option of creating a row store table or a column store table, and I'll be showing you the different perspectives as well. See, this is SAP HANA Studio. It's Eclipse based IDE. So SAP HANA Studio is a one-stop solution for both modeling and administration process. It's a one-stop tool for the developers in HANA landscape for defining the tables, for setting up the data provisioning, for making different data models in HANA. And SAP HANA Studio is organized into various perspectives. Now, what's a perspective? A perspective gives us all the information, functions, and the tools which are needed to accomplish the tasks. Developers have their own preference in working with the screens, and hence the perspectives can be customized. So when you start the SAP HANA, you can decide upon several perspectives. These are just the predefined user interface layouts or the views dedicated for different roles. So here you can see the different views like properties, then here you can see the properties, then the job log, navigator, and then we have the history. So these views are just the screen elements, a collection of these displayed views, right? Like this view is right now here, this is here, and this is here. So the collection of these views with their placement and within the screen, because they have their particular placement in screen, it builds up a perspective. So from here you can open a perspective, whatever perspective you want to wish to open. You can see over here these are the different perspectives we have. We have the modular perspective, which is used by the data architects to create different information models, and it provides the views and the menu options that enable you to define your analytical model. For example, you can create the attribute views, the analytic views, or calculation views of SAP HANA. Then we have the debug perspective, wherein you can we have all the menu options and the views that help you to test your applications. For example, to view the source code, or to modify or monitor the variables, or you can set the breakpoints. Then we have this is the debug one. Then we have the administration console also, wherein it reflects the pre-delivered administration perspective. Here you can administrate the SAP HANA instances depending upon your user rights. Then we have the Documentation overview also, which links to the current available documentation. Then we have the development perspective, which is a very important one, wherein you can see all the systems which have been registered. And I'll just cancel it because we have already with us this SAP HANA modeler perspective and SAP HANA development perspective. You can see over here. See, SAP HANA development perspective builds upon two additional major views. Otherwise, it has got three, that project explorer, repositories, and the systems, which is we call a navigation view as well. So the first is the main we have is SAP HANA repository. This view enables you to browse the contents of the repository on a specific SAP HANA system. You can display the package hierarchy and use the checkout feature to download files to the workspace on your local file system. The SAP HANA repositories views is a list of repository workspaces that you have created for development purpose on various SAP HANA systems. So generally you create a workspace and then you check out the files from the repository and then do most of your development work in the Project Explorer over here. The Project Explorer view shows you the development files located in the repository workspace you create on your workstation. You use this Explorer to view and create and modify the development files. So using the context sensitive menus, you can also commit the development files to the SAP HANA repository and then you can activate them. Then we have this our system view, or we call it otherwise navigation view, wherein we have these different nodes with us. That is our catalog node, the content node. These are the main two sub nodes, and we have the other ones, the provisioning and the security. In the catalog node, basically all the actual tables which contain data physically appear over here. It contains all the schemas. This is our schema, and in which all different physical tables and indexes, procedures, synonyms, sequences, the views which are there, these are all appear over here in the catalog folder. In SAP HANA, only physical tables actually carry the data, and all the information models created in the modeler are saved as database views only. Okay, so if you expand this node, you will just see a list of all the schemas which are used to categorize tables according to the customer defined groups. In other words, these schemas are used to group the tables into categories which have some specific meaning to the user. So each schema contains a folder for column views, for procedures, for tables, for views, and the schema with your username, because this is my username. So the schema with your username is the place where you can actually create all the objects and you can modify them. In the rest of the schemas, you can only use their objects, but you cannot modify or delete them. Over here, as you can see, if I just right click over here, then I have this option of creating the new table, and then opening I can just open the SQL console, and wherein I can write the commands. We have the option of writing the commands also, like create table, alter table, insert values into the table. We can just write those SQL commands. This is the one way to create the table and enter the data. Other is to just use the graphical user interface, that is just to use these menu options and create the new table. This is our schema. Here we can create, but if you open over here, if you just try to go somewhere else, here you are not able to create any of the tables, or you cannot just modify. You can just view the data. You cannot do any modification. You are only allowed to do the modification, only allowed to create the tables or the different objects in your own schema. So this is all about catalog. node. Then we have the content node, which displays the data from a data modeling perspective. So it just represents the design time repository, which holds all the information of the data models created with the modeler. So all the attribute views, all the analytic views, all the calculation views, these are all created over here, and these models are stored in the database tables, which are stored in the catalog. Content node just provides a different view on the same physical data. Physical data is stored in the catalog node, and the views, which just provides the different dimension, I would say the different views of data, are there in the content node. So all the information models like analytic views and attribute views and calculation views are organized in the packages. So in this package, we have this package with us. In this package, we can create these different views. Then we have the security node as well, which navigates the to user and role settings. And then we have the provisioning, which is used for data provisioning, for getting the data from different platforms, from different source systems. Now I'll just show you, just a second. So now I'll just show you how can we create the table. So over here, if I just right click and choose new table, then I'll have the option of choosing the type of the table. You can see over here, I can either choose row store, column store, or table type. See, row store, I've just explained you that only the storage, the way we create it is not changing, is not changed. It's the same way, we just choose the type to be different. But the backend, at the backend, how the data is stored is changed. In case of row store, if we choose row store, then the sequence of rows will be stored in the contiguous memory locations. But if we choose column store, then the sequence of columns will be stored in the contiguous memory locations. So here I'll just let's just create the table geography, right? And then in the table geography, I'll just let's just create the column store. And here first is the city, I'll say yes, and where this is, here we specify the data type for the column. You can choose from here different column data types are there: blob, clob, then small int, we have text, we have integer, varchar. So we want varchar, and we want the city to be at least 25 characters long. Now to add a new column, you need to click over here. Now the second column is the state, right? And here also we want it to be varchar, so I'll just leave it as it is. And the state I would choose to be again 25. Then again I'll say pin code, and the pin code should be just 6 characters, right? For next column, again click on add, and here you can write maybe country, and this is again say 25. So this is how we this is just the easiest method of creating the table. You can just choose it to be a key, right, so that it is the primary key, so that all the records are unique to it. But for that you need to have the unique values in it, so that all the records are uniquely identifiable based upon the value of this particular column. So it depends which column you want to use as the primary key, right? Okay, pin code I deleted by mistake. It's okay, that doesn't matter. right? And here you can specify whether you want to specify the null value or not. You want to allow the it should not be left null or what. See, if you choose a column as a primary key, then automatically it specifies that you cannot define it as null. A value has to be specified. Otherwise, if you want some other value to be present always and you don't want it to be left as null, then also you can again specify over here that it does not have to be null, or it's up to you. And here you can specify the default value as well. By default, whatever value you want to enter, that if you don't specify any new value while entering the data for the record, then this particular value should be inserted. So you can specify over here, and here you can specify the comments. It's just for your own purpose. So this is how the table is created. Now let's just execute it. You can see over here it's executed successfully. Here you can see the statement create column table. This is executed because at the back end this table is this command is issued and this command is executed. So it's the same if we provide over here in the console, SQL console, if you write just create table and specify all the parameters, then this command is executed. So that's the same way it's executed. Now let's just refresh it so that it's visible over here. Yes, the geography table is visible over here. Now I'll just show you how do we create a row store table. The same way it's created, nothing is different, only at the back end it matters, it changes. The front end is just same. I'll just show you the test row. Let's see, right? And here let's choose the row store. Let's choose over here ID, and this time we'll choose integer, and then name, and let's just specify 20, and age, and let's just specify integer. Right, and we can specify this to be the primary key. Okay, and now let's just execute it. We have not done anything different, it's just same like we did in column store. It's just that we have just created the row store. We have just chosen the type over here as row store. Everything else is same. Let's just execute it now. You can see over here this table is created, but now the syntax is different over here. Earlier it was create column table, now it's create row table. Rest everything is same, and this is the name of your schema dot the name of the table. So this is how a row store table is created. Now I'll just show you how do we enter the values into it, how do we insert the values into it. Let's just open the SQL console and then insert values into insert into, then the name of the table, we have geography, then values, and then the whatever values we have. Now if I remember, we had 3 columns. Let me just see. Yeah, it's opened over here. Yeah, city, state, country. Let's just provide the values because it's varchar, we have to provide in quotes. City, name, country, so it's just let's say New Delhi. and let's say X, it's the capital, but let's just provide X, and then India, and that's here, and we can just Aarhus, then it's ABC, and it's Denmark, or we can just write one more, Melbourne, and it's Australia. So let's just try to execute it. So this is how now 3 statements are executed and all these values are inserted. This is how we enter the value, how we insert the values into the table. Now let's just enter the data into the row store table. So we'll just write insert into, the name of the table was z test row values, and the columns were ID, name and age, and name was the varchar, so we just need to provide the codes over there, 1A and say 10. We'll just enter the multiple values simultaneously. We can execute the multiple statements like that, and because it's the primary key, it has to be unique. We can enter the same values over here, that doesn't matter, 13 and say 12, right? And let's just execute it. You can see over here that this is also executed. Now entering the data into a row store or a column store doesn't matter. It's like the difference is not there. It's the same procedure. Creating the table is also the same procedure, only you have to select over here while creating whether you are creating the column store or you are creating the row store. And if you are using the SQL console, then you have to write create a row table or create column table. So it just depends upon the type of the table. You have to use either row or column, otherwise everything is same, the primary key, the data types, and how we enter the field names, and how we can create the primary key of the table, and all these things are just similar in both the cases. So that's why it's called the hybrid store. We have one more option is over here, that is to create the table type, right? So what's that? We can create the type also, so that it can be used to create the different types. I'll just show you how do we do that. If I choose just over here, if I choose from here the table type, right? So now whatever name I provide over here, whatever fields I provide over here, this will just create a type. Okay, now in future I'll be able to create the tables of that particular type. It just creates the object type. I can make many instances of that type, like we have varchar, like we have integer. It just creates the type of the table, that it means it will have these particular columns, and all the columns will have this data type, this length, and this would be the primary key. So this just creates a particular type, and you can create many instances of that type in future. So this was all about creating different tables and why it's called a hybrid data store, and what's the basic difference between row store and column store. And in modular perspective, we'll be able to create different kinds of views from here I can create the attribute view or the analytic view or the calculation view. These are just created on top of each other. Most basic is the attribute view, wherein all the attributes are saved like a table. That is, it consists of simple fields. Then on top of attribute view, the analytic view is created, which is based upon the join of different attribute views or the tables. And then on top of analytic view, the calculation view is created, which is the join of different collection of different not the join but the collection of different analytic views, wherein all these views are combined together. So there are many requirements wherein analytic view is not sufficient, it does not fulfill the requirement. In those cases we just create the calculation view. From here we just choose new and then we create the calculation view. So this is the modular perspective, wherein we can create the different information models on top of the tables which we have already created. I'll be showing you how these views are created in different sessions. This is all for now.